Okay, good morning class. Today we're looking at analytical geometry. We're looking at the examples for exercise 4.3. And exercise 4.3 is on page 90. What? 92. 93. Okay. And the first example is on page 91. Okay. So now we need to look at inclination of a line, working out that angle. Okay. So something to note at this point is that, why is it not putting it down? Doesn't be. Okay. We know that for any points, the gradient of PQ is going to be the change in y over change in x. If a line is parallel to the x-axis, the gradient is 0. So make that note there. If a line is parallel to the x-axis, your gradient is 0. If it is parallel to your y-axis, it will be a gradient is going to be undefined. Okay? We made this notes last year already. And if we say that lines are parallel, what do we know? Gradients are equal, and also if lines are perpendicular, the product of the two gradients is -1. That is the summary of our last lesson. Okay. Now we look at the inclination of a straight line. The incline or inclination. Now we define as the inclination of a straight line as the positive angle theta that the straight line makes with the positive direction of the x-axis, where theta is greater than or equal to 0 or less than or equal to 180. People, by saying that, what does that mean? What does that mean for theta? That means to say that theta can either be in the first quadrant or the second quadrant. If it's in the first quadrant, the angle is acute, or in the second quadrant, the angle will be obtuse. Okay, you guys understand? So here again, there is an example of what they're trying to tell you there, is that, can you see, it always opens from this axis onto the line. Can you see that, people? Always from that on onto the line. So here the angle is acute in the first case, otherwise the angle is obtuse in the second case. Okay? You all understand? But what you notice about this gradient here, this gradient will be positive while the graph is increasing, not so. The gradient is positive, so the theta angle will be greater than 0 but less than 90. However, when the gradient is negative, which means to say less than 0, your theta angle will be greater than 90 but less than 180, which is in this case your obtuse angle. Okay, so make that note there as well. In both of these diagrams, theta is inclination angle of the line of the given straight line. Consider the straight line AB in the diagram below. Theta is the inclination of AB, so BAC is equal to theta. Let's go see here what they're talking about here. Right, so basically here, we are given this angle to be theta according to what we have read here, but we know that opposite over, we know that BC, this is change in y, not so over change in x. BC over AC is equal to your gradient, not so. You all agree with that? It's change in y over change in x. If you're using trigonometry, BC is also equal, BC over AC is also equal to what? Opposite over adjacent, which is tan. So if tan of theta is equal to BC over AC and the gradient is equal to BC over AC, what can be concluded from here? We then can say, therefore, tan of that angle is equal to the gradient, and that's what we're going to be looking at today. Okay? So make that note there. The tan of theta is equal to the gradient of that line. Am I moving too fast? Huh? Not yet. Okay. Right, here it says that's the positive angle theta which makes a straight line with a positive direction of the x-axis such that theta is equal to m. Supposed to have been tan of theta equals m, where m is the gradient of the straight line. That's what we just said now. Okay. Again here, we have that note we made already. Alright, so let's do the first question. If tan of theta is positive, that means that the gradient is positive, is acute. If tan of theta is negative, of course the gradient is going to be obtuse. Okay, that's what we're trying to say. Note that we exclude 90 degrees since tan of theta is undefined at 90. Okay, so then I should have added here equal to 0. My mistake. It should have been equal to 0. So just add that thing. Okay. People in example 1, we are told on page 91, determine the inclination of straight line L if the gradient is L, the gradient of L is as follows. Work correct to two decimal places when necessary. So let's look at the first one. If you want to work out the gradient of this line, if we now draw a line here with a gradient of 4, it will look something like it. Not so, and that is the angle they want you to work out. Okay, you guys understand? And this is your angle, theta. So what do we say? Tan of theta is equal to?
Mr. Bodhi?
Gradient. Yes, miss?
Hayat Tadish with you?
She is, yes?
Can she come to the office with the bags, please, sir?
Okay. You like to go with your bags like that? You don't look like you say to the maths. You look like you. It's the highlight of your day. Don't forget, no? Exercise 4.3 is our motto tomorrow. Okay. And don't be like somebody we know. Okay. Choose the whole biology over. What's life science you call it? We used to call it biology. But anyway. People, what is the gradient of that line? 4. So we say tan of theta equals. So how do you work out theta? Take tan over. Becomes arctan of 4. Okay? So plug that into your calculator. Arctan of 4. So they give you 75,96. Okay. Do you guys understand? Easy, no? That angle there, the straight line makes with the positive x-axis is 75,96. Okay. Let's look at B. This has a negative gradient now, no? So it's going to be a decreasing function. Okay. So where do I start? I start off by saying that angle that we are going to calculate is that angle there. You will understand. So we say tan of theta is equal to? Tan of theta is equal to? M, yes. So tan of theta is equal to negative 2. Now you do your thing. Now you work out theta as we did before. Okay. Alright, so now what do we do? So theta is equal to arctan of negative 2. That gives you an angle of which arctan of negative 2. Negative 63 comma negative 63 comma 430. Okay. We say, okay, hang on. But we didn't say this angle is going to be obtuse. Is this obtuse? No. You see, this angle that was calculated here is in actual fact this angle here. That is negative. Remember, that is 0 here, no? So it's going in the negative direction. Negative 63 comma 43. So how do we get this angle here? Remember, these are angles on a straight line, which is equal to 180. So what do? We add 180. So make a note here. Whenever the angle is negative and you're working out inclination, not whenever, any time in your life. No. Only when the angle is negative and you're working out inclination, we add 180 degrees. We don't always add 180, only when the angle is negative. Okay. So therefore, theta is equal to, so we say plus 180, gives us an angle of 116,57. 116,557. Okay, let's carry on. Let's look at example 2. There's a note here that they gave you. Note that if tan of theta is positive, then theta is an acute angle and theta is equal to the calculator angle. If tan of theta is negative, then theta is an obtuse angle. Then we take the negative angle and we add 180. Okay. The only time you add 180 is when the angle is negative. Verstaan jy nou? Ja, okay. Let's look at number 2. Example 2, and example 2 is on page 92. Example 2 is on page 92. Okay, that's a bit different. Okay. The question says determine the inclination. Determine the inclination correct to 2 decimal places when necessary of a straight line that passes through each of the following pairs of points. In the first case, we have E which is negative 2 and negative 4, and F which is 7 and 5. Where do we start? To work out this angle, what do we need? The gradient. The gradient of EF. So work out the gradient of EF quickly. Alright, so it's going to be y2 minus y1 over x2 minus x1. So it's going to be 5 minus 4 over 7 minus 2, which is 9 over 9, which is 1. So we do go from here. We go with tan of theta is equal to the gradient. And my gradient here is 1. So tan theta is equal to 1. We go arctan of 1, what do I get? 45 degrees. Okay. Will you guys understand? No. And look at B. B, we have the point Q, which is negative 1 and 8, and P, which is 3 and negative 2. Be perfectly? This angle here is 45, no? So when you start here in B, we work out the gradient of QP. Right, do you think quickly? Can you work out your angle? You will get negative 5 over 2 as your gradient? No? Sorry? You left it as 10 over negative 4. It's fine. So it's not your final answer, so it's fine. You can carry on with that. Alright, so if we go arctan of negative 5 over 2 gives us negative 68, 2. No? So what do I do with that? Add 180 degrees Y. An obtuse angle. Okay? Add 182 that answer. Give me an answer 111, 0 8. The theta is equal to 111, 8. Was there any confusion? No. Let's go to example 3. On page 92. Okay, so the question says calculate the inclination of the straight line y plus 3x is equal to 4, corrected 2 decimal places. Alright, so to work out the inclination of a line, what do we need? We need the gradient. Is this equation in the form of y is equal to mx plus c? No. How do we get it in that form? By taking the 3 over. Hence, how they got? Y is equal to negative 3x plus 4. You guys got it? So do this calculation quickly. Work out the inclination angle. Okay, so tan of theta is equal to the gradient. So we say tan of theta is equal to negative 3. So theta is equal to arctan. Oops. Arctan of negative 3. Use the calculator because shift 10. Negative 3 gives us negative 71,57. So it's a negative angle. So what do we do? Add 180 degrees to it. So theta is equal to 108,43. Okay, people see any confusion? So with that you should be able to do exercise 4.3. Let's call it. Okay. Who's capturing the overpass today? Who normally does it? You don't do. Thank you for all those times. Yes. Stop the video at this point, okay?